Good to be here with everyone. Given it's a smaller group, I actually would love if I could have some help from the kernel crew and kind of like doing a brief introduction of who's around the room. If people wouldn't mind within like 30 seconds each, kind of just like telling Shresth who's here with us, just like what you're up to, what you've been working on. I see Deep, I see Alp from KB11. If you guys wouldn't mind maybe helping kick it off, then we could go to like Nitesh and Kritika and maybe others from beyond KV11 who are also here. But Al, Pradeep, would you mind?
Yeah, hi. I'm Mike from New York. I do work on a RWA focused blockchain, and I'm doing a project related to cross-chain DeFi vaults and agentic uh, e-commerce, autonomous e-commerce. I guess
Thank you. Thank you.
that's
Thank you.
the
Thank you.
summary.
Yeah. Yeah. Al, great engineer, currently at Plume, also working on these cool projects. Deep, please.
Hey Shresth, my name is Deep. Um, my background is in machine learning and risk, and currently I'm working on cryptoeconomic systems for establishing common knowledge and ideally flagging propaganda, misinformation, things like that.
Yeah. Thank you. Nitesh, please, if you wouldn't mind.
Hey, I'm Nitesh. I live in the Bay Area. I've been a lawyer in India and the US, and I'm currently working on a legal knowledge platform with the goal of structuring case law data in a way that improves AI reasoning outcomes.
Thank you. Thank you. Maybe Verber or Charles from past blocks through here if you'd like. And Kritika, also from KB11.
Uh, I'm sorry, like I'm in the other meeting.
No worries.
So,
We'll hold off for now, Kritika. Verber or Charles?
Go
Good
ahead.
afternoon. Sorry. I'm Werber, I'm Laura. I am right now working the Liga Collaborative of the People is a grassroots organization where you are creating a data system to create a data proof system for collective class and legal actions for the territorial challenges.
Oh, thank you. And Charles, yeah.
Sure, yeah. KB2 and a bit KBX and in and out and just love kernel. The keywords are community wisdom gardening. I'm a transcontextual collage artist and a radio guy for a long time. Having gone through, I'm a kind of refugee of collective intelligence as well. Come through to embrace collective wisdom. So love to jam on that, and I'm kind of really curious to tune into the game aspects of community gardening, community wisdom gardening. Check.
Yeah. Thank you, Charles. Thank you. Yeah. So this module, Shresth was in Genesis blog, so I'm gonna be excited for him to kind of tell his human story, but we're also here to hear him talk a bit about Pod and his work on scaling a principled game. And the way that I would describe this is that, over the course of the last like at least decade, but maybe you could build the root system even deeper than Ethereum and Bitcoin. People have been working on scaling blockchains and trying to figure out like how this game that has a defender's advantage that requires some cryptography and requires some economics could be better and better and serve wider and wider groups of people concurrently and simultaneously. So for a long time, the work on scaling blockchains flowed through the work of like how do people come to consensus and what are the trust assumptions to do so. Um, but if I kind of like put that to the side for a second and we can assume that Shresth is going to give us maybe the next iteration of that particular game, I will just do a bit of broader framing on this module. So if you take it most specifically and literally, it is about how we scale these decentralized networked virtual machines. And we are particular about not always using the word blockchain, as you'll see with Shrest's work. In fact, Pod, what he's working on, is not a blockchain, but is a evolution of the game that blockchains have brought to us. This module includes two crafted readings, one on censorship resistance, which we drive home as the number one critical need to speak truth to power, and the way to do so using structures that are perhaps sometimes a bit like subversive. And this goes back to module 0, where we had Mei Ko from Khan Academy talking about this idea of joyful subversion. And in blockchains, I think that, instead of like fighting the rules that may, there's an approach to building technical solutions that might just increase this value of censorship resistance. But beyond that, there's this module on learning, and if you look kind of on the left side, this module in large part describes one game as a principled game as uncensored learning, and we encourage this always as like kind of like a meta point when we have a fireside guest, is just kind of like try our best to understand how they learned the things that they learned. So Shresth, as you are sharing about Pod, I hope that a part of it can be just the journey that you've taken to learn things, because you've learned a lot of things over the years to be able to come to these novel points about where we might go next. There's a lot in the crafted materials. The one maybe I'd point to for later for anyone who's maybe struggling with anything is this module on Duende and Deep Song. I think that the music that we listened to at the beginning would kind of rhyme with this, and it's a really nice read if you're kind of like trying to work through some challenge or some tougher time. But I'll leave that for now, and I do want to point out this module that was really inspired by the Flashbots folks on committed participation, and this also to us represents a principled game that might be worth looking at. It's our first module that tries to look at how blockchains and LLMs both find middle ground and where privacy helps to make that happen. And it references a series of talks by the Flashbots team from about a year ago, where they did a series of workshops on MEV research and how MEV research, and specifically to focus on like who gets what information in what order, could be generalized to LLMs. And so there's some links, if you go through this module, that are, we think, worth paying attention to. So that's all the like background on module 6. Shresth, you've already also gotten a bit of background on some of the people in this cohort who are here today. We'd love if you wouldn't mind introducing yourself, introducing Pod, perhaps a bit of the human story of how Pod came to be, and what it is, and perhaps how it might be meaningful to some of the people building in crypto today.
Sounds good. Thanks a lot, Vivek. And thanks everybody for joining today. I was part of the kernel Genesis block 2020. So like it's half a decade, more than half a decade. So 5 years in crypto. And that I was not my start, but I was still kind of very early on then. I remember like just finding it through Gitcoin somehow, and then joining on the Discord and like no on the Slack, and then I met some folks from Dorg through the Slack, and then I was working. I was working for a DAO in 2020 that was like paying me in stable coins. Was when like nobody was talking about stable coins, and I was making my salary in DAI. And then through Dorg, I got to like meet my first clients that I was working. Dorg is like a consulting DAO, and they work for like different DeFi projects during that time. So I was working. The first project I worked for was Paraswap, which was like a DEX aggregator, and like I remember like building algorithms for them that would trade hundreds of millions of dollars every day, and the DeFi bull run happened. It was crazy times. And Paraswap decided to hire me full time, and I joined Paraswap, and then I was working on the smart contract layer, and just like of course like a lot of learning that I did through kernel and meeting people kind of played along. And then at Paraswap, once I understood how the kind of smart contract stuff works and the DeFi works, I went down the stack, and I went into like understanding how the cryptography and consensus work. So I did some research on that, worked with some researchers in that space, then joined like a science consulting firm called Common Prefix, which I just met the founders through my work at Paraswap, because I was at some conference, and there I met somebody. And it's kind of just like looking back, it all connects to kernel, because like if I wouldn't have joined kernel, I wouldn't have joined Dorg, and I wouldn't have met Paraswap, and I wouldn't have joined the consulting company and so on. And finally, fast forward today, I spinned out this new company out of Common Prefix, which is a science-based consulting firm, and I'm very excited to tell you more about Pod. So that's kind of the human story of it. And I'm very happy that I was part of Kernel 5 years ago, and connecting the dots. It was a critical moment in my life, because I had no clue what Kernel was. I literally was just some online community that I found somewhere, and I just joined it, and then rest is history. So I hope everybody's kind of all of you here can look back 5 years later and be like, okay, this is where I picked up this, and then it changed a lot of things in my life in a butterfly effect.
Like we can hope, and I really enjoyed meeting a lot of the people in KB11. I'm really grateful for them for being here, and I have also appreciated the learning path through the smart contract layer down to the cryptography layer, and I think it's going to make itself clear through what you share with Pod. So I'm not sure if you have anything prepared to share on the screen.
I have a slides. I wanted to put some slides on, so let me try to share my screen, and just let me know if you can see my screen.
We can, yes.
Sounds good. Feel free to interrupt me if anything is not clear, given that it's a small group. We can even have a more kind of conversation instead of me presenting. Generally, as I was saying, I've been in the Web3 space, in the blockchain space for quite some time. Tried building applications, tried building infrastructure, and then like one day we were looking at a board. We came up an algorithm for flashbots, and we realized that we've been thinking about Web3 completely differently, and there's ways to scale Web3, which is a new kind of a completely new approach than what Ethereum and the all L1, L2 architecture is doing. And that's why we decided to spin out Pod. And I'm going to try to give a bit of intuition to everybody here and like what this kind of new dimension of scaling is. And it would be great if if people can get that intuition of why this can be a potential direction, irrespective of if you like Pod or not, but just the idea of what we're trying to do. So if you think of blockchains protocol today, right, they look like a pipe, right? And there are transactions coming in from one side of the pipe from all of the world. We call this the mempool, and there are the pending transactions. And then once they go through the pipe, they become finalized, and they're the green transactions, and they're confirmed. And this pipe, the main job of this pipe is actually just to order transactions. So what it does is it says, okay, this is the first transaction I saw, this is the second transaction I saw, this is the third transaction I saw. And everybody agrees on this order. Everybody says this is the global order of transactions. Because once you have this global order, what you can do is you can run a deterministic machine. You can run a compute on top of it and be like, okay, this is the state of the blockchain. And also you can see that, if I was trying to double spend same money, if I was trying to send the same money to Vivek and to Kelly, the first of the transfers will get accepted and the second one will fail, right? Now, the problem is if you open this pipe up, it looks like this, right? So there is like a bunch of validators around the globe. And when you send the transfer, let's say Alice sends a transfer, the transfer first has to go to the current block proposer. There is some leader who's block proposer or sequencer. And this happens in almost all of the existing blockchain protocols. And this block proposer then transmits it to all of the validators in the network. And then they, talk among themselves. They do a lot of argument about how do we order this thing? Where do we put this transaction in? And after several rounds of communication, they finally output the green ledger saying, okay, the order of this transaction is X. And this has several problems. One, it requires several rounds of communication, so it's slow. Two, it's expensive because you consume a lot of network bandwidth. And three, it doesn't scale because the moment you have a lot of transactions, you create a choke point where you're waiting for other transactions to be confirmed before you can process more. So this is seen again and again, and we know that whenever some kind of a huge spike happens on the traffic, the gas spikes and blockchains become unusable. And there's several approaches trying to kind of fix this problem. Okay, so if you look at, let's kind of zoom out and see how traditional web applications work. So if you think of, web applications, like if you use a bank or a Facebook server or any of that, you just send like a message to a server and that server immediately confirms and you're done, right? It's like one round trip end to end. It's like 150 milliseconds, super fast. You don't even feel it's almost real time, right? It's as compared to like a blockchain protocol where it's like you have to wait for several seconds. So the motivation is there a way to build something which is as fast as this and much more scalable? So yeah, can we build Web3 as fast as a Google search? And what we're saying is we're questioning one of the foundational building blocks of blockchain. We're saying let's remove the idea of having consensus. Let's remove that everybody has to agree on everything. Like if you think about this, right? Like if I am doing a transaction with Vivek, why should somebody in Argentina doing a transaction should agree on? Like these are completely independent transactions. They should not need to wait for one another, right? So somehow it's obvious if you look at it that independent things should not wait for one another, should not block one another, but that's not what happens in blockchains. Currently, it's a totally ordered ledger, which makes it slow. So let's look at a very simple protocol, and I will motivate that this is already good enough to kind of solve the Bitcoin's vision of payments. You have a set of validators, right? Some of them can be malicious, and then like the Web2 servers, you just send a message to all of these validators. They don't talk among each other. They don't agree on anything. They just locally validate something and sign and send you back. That's it. That's all they do. This protocol will be as fast as your Web2 service. And I'm going to convince you by the end that this is enough to solve the double spending problem that Bitcoin wanted to solve originally. Okay, so the payment system is very simple. When I send a transfer, all of these validators check that you have enough balance. And the moment you see 2/3 of the network saying that you have this payment is valid, your transaction gets confirmed. So that's all. These validators don't talk among each other. And whenever they see a 2/3 confirmation, they execute the transaction. They execute the payment. you can already see that there can be a case where like 2/3 of the network is processing all the payments while the rest of the networks is not even aware of what is happening. And that is totally fine. Or like different parties might see different balances, but that's also fine. And the basic argument is that if you have 2/3 of the network saying that this payment is valid, you cannot have a conflicting payment without having one honest party that has to like equivocate. So if you look at the intersection argument, when you have 2/3 and 2/3, you have at least 1/3 in the middle, which means you need more than 1/3 corruption, which is the basic assumption of proof of stake networks. So as long as our corruption is less than 1/3, it's guaranteed that we cannot have two transactions both achieving this 2/3 confirmation. So, you know, in the original kind of picture, I showed this like narrow pipe of consensus. And on the other side, we have this kind of now thick pipe because transactions are no more waiting for one another. They can be processed completely in parallel. And this allows you to really confirm things almost instantaneously at the latency of traditional web services, and also achieve like much higher throughput. Currently we are expecting around 1.5 million TPS with like 200 millisecond confirmation time. So this is the level of NASDAQ and other like exchanges even. Yeah, that was a quick summary of what we're doing. I'm happy to like, you know, tell more, answer some questions, or go in depth of the stuff I mentioned.
Thank you, thank you, thank you. Yeah. Anything from the crowd before I ask if you have anything, please feel free. If I could ask one follow-up, Shresth, if you can go back to, if you don't mind, the validator slide. So I think that this part is helpful because it's kind of like framing the rules of the game, and you were talking about the corruption. Yes, this side exactly, that honest validator slide. This honest validator not being possible for it to be part of both quorums, and this 1/3 requirement in proof of stake systems. Can you kind of help just a touch more in understanding how this helps to ensure that something can be finalized without any round trips? That's something that the visuals are really incredible throughout the deck, but that's one part, like how things can be finalized without a round trip because of this point.
Yeah. So I think this is where you can see it clearly, right? You have Alice who's trying to send money to Bob, and what happens is Alice just sends messages directly to the validators. Some of them, so here we have just 1, 2, 3, 4, 5, 6, 7 validators, right? And we have 2 of them which are malicious. It sends to all of the validators, and then the moment it sees 2/3 of them saying this is a valid transfer, so this is like half a network round trip, you know it's done, it's confirmed, and you're guaranteed to have 2/3 because, you know, 1/3 malicious might just say, I'm not going to respond because I don't feel like, but you have the rest 2/3 which are guaranteed to be honest. So you are guaranteed to get confirmation in one round trip based on this assumption. And on the other hand, even if the you know, 2 of these malicious guys try to double sign, so, you know, you can be malicious, Alice can be malicious and try to double sign transactions, or have transactions which are spending the same nonce, you will not be able to collect how many we need, like 2/3. So it's 1, 2, 3, 4, 5. You need 5 attestations to get 2/3. So if you have 7 validators and then you have 2 malicious validators, you cannot have a quorum of 5 and 5 because the intersection would be 3. And you're only allowed to get 2 guys malicious, but not 3. So that protects you, right, from being, from the double spending. Does that answer your question?
It does, precisely. Thank you for using both slides to help with that. And it represents, like, this is the nature of the game. And it's been kind of like you call them like the golden gooses, I think, in academia, where you say like double spend, it must require global consensus. How could it possibly not? And what I've really enjoyed about both you and others on the pod team, I've seen Alex do this as well, is you've been willing to look at these with fresh eyes.
Yeah.
And if we zoom out past the deck, I know we only have 15 minutes. I want to talk about a couple of other golden gooses. We can talk a bit more about pod in terms of like some of the proposals that you've made, but maybe you could take a second to tell us about sparse clients. And
Yeah.
the golden goose that I think that sparse clients is after is the zero knowledge approach to everything. And maybe that could illuminate this kind of like continued way that you guys are trying to look at ways to see how the game can be improved.
Yeah, definitely. So first of all, like, I love cryptography. I love cryptographic primitives. I love ZK as a primitive. I don't have any, like, bad feelings that I'm not anti-ZK. Whenever, usually in the space, whenever people use ZK, they're actually talking about the primitive snark, not the privacy primitive ZK. So I'm just going to make it clear that we're talking about snarks. And snarks on themselves, they're like a computation compressor, right? Like, you might have heard of like file compressors, right? Which is like compress your file into a smaller file. The way to think about like snarks is like they compress computation into a smaller computation. And that's all they do, right? That's the magic that they have. A supercomputer can do a big calculation and you can verify it very easily on a smartphone, right? Now, we have, Ethereum has been proposing this, and a lot of L2s have been trying to use this to allow to scale, right? It makes sense that, there can be big servers who are validating the network, while you can have a smartphone that can run a light client which just verifies the proofs, the ZK proofs. And that makes sense, right? Because there is this disparity among compute power. But then if you kind of open the box and think a bit more, like, why is my smartphone verifying this global state of the world? Like, why does my smartphone have to care about what happened in Argentina? My smartphone cares about what is my balance and what transactions I do, or maybe, what is the balance on Uniswap. So the idea of a sparse client is, how can I build a light client which is not talking about the world state, but is only talking about the state that I am interested in? It's kind of sparse, while it gives me all the guarantees. And because I only care about very few things, I should be able to validate that. I shouldn't need any ZK. I shouldn't need any complex things. I have to verify like 10 transactions that are related to my interest, not like the global traffic of the whole blockchain. That's the key idea behind it.
Yeah, there's a question in the chat that I feel like we might be able to use an example here. Verber talks about the perspective of validation of data. So traditionally around blockchains, you might think about finance related data. Verber says, and you can please speak up if you'd like, I'm investigating how to create legal data proofs. And can you talk about how blockchains can solve this? Is this maybe an example for sparse clients to you, that it's like a very specific example, or would you like to hear more?
I'm just let me make sure I understand the question. Legal, what do you mean by legal data proof? Is it more like that the contract is correct or something?
Yeah, right now you have a data system when you have the data proof for organization, for the people, for anything, but we need to bring this for the legal procedures. So right now we are using the IPFS to storage the metadata on chain, and use it to of chain and use the CID to prove that this data is the original information that someone put in our document. So we use this hash to prove that this is the original information. But I like to listen more about this, how we can use this blockchain for this specific solution to bring this for legal procedures.
I think you can definitely like put the smart, like if you could code the legal contract as a smart contract, right? Then it's like rule is law and everything has to be enforced on chain, right? Assume that we are, for example, getting into an agreement that if I give you like $5 in future, you must pay me this and that. You can enforce this completely on chain. I can see that potentially being used, or like people having like standard templates, and then that this contract has been used by these parties over past N years. So this is kind of, if you can verify that, then that it's a valid contract, for example. Does that?
Yeah. I think that gives us a starting point. And I want to broaden back for the use case of pod. And I know that this is all related. I think the way that I would describe it, how I understand it, is like there's so many things for which total ordering is not actually the requirement. And that has been this like, you can't touch total ordering, it needs to happen. But now, if you kind of take that away, if you cut that out, now you start to think about all these different things that are possible. But what I would love now a bit of nuance on from you is, in what situations does total ordering really, really matter? And what are the things that you've been seeing, which are like kind of the first places that you would like to go with pod, where, okay, these are big examples currently happening on chain already. And I think auctions is one that I've seen you talk about. But maybe there's auctions, maybe there are other examples where you don't need this total ordering. And so there's a real reason to be kind of like re-looking at this, rethinking about this.
Yeah.
Vivek, can I pile on to your question? I
Yeah.
think it's related. So your question is about when and where is total ordering required? And I guess mine is, I'm still actually trying to wrap my head around why is it not required? Because when we say that there are some honest validators and some malicious validators, and some validators may be making a mistake, and we can club them also into the malicious group. But how do we know which one's right and which one's wrong? It's because they have, run all the transactions maybe in the right order on their end, and then arrived at consensus about the ordering of the transaction. And that's how we know they're right and they're wrong. And so doesn't that necessitate total ordering?
Thanks for both the questions. Let me start with your question first, the last question, and then can go back to Vivek's one. So there is no way to know if a validator is honest or malicious. Okay, so even with today's blockchain, there's no way to distinguish from outside if a guy is behaving honestly or maliciously. The only way is to know is if he double signs something. So in proof of stake networks, the biggest failure is when you like sign when you were required to sign only once for a particular, let's say, nonce, and you double signed it. If you double signed it, you have a proof that says, here's transaction A and transaction B. You should have only signed one of the two, right? Why did you sign both? And this is what Ethereum slashes you for. Now, I think the intuition that you're trying to put forward is like, how do I know that myself, if I'm doing the right thing or not? If I'm, if my balances look completely different than your balances, like, am I like in a wrong state, right? How do I know that I haven't entered into something that will never resolve? And this is what we call as like eventual consistency. Like the system guarantees that eventually both of us will agree on the same state. So think of it like like sets, right? You can have some elements of the set, I can have some elements of the set, but anytime we both like look at our state, we can just do a union. And the union of the set is still is the valid set, right? So we can converge on the same state. And we know that, as long as my set locally is valid and your set locally is valid, the union is also valid set. And that's already quite common in like database literature of like eventual consistency. So that's one. And getting to Vivek's question on applications. So CORD doesn't say that we cannot have like ordering, like you can build ordering on top. In fact, ordering is like kind of building synchronization on top of pod, and you can build applications that require ordering. What we're saying is you don't need a global ordering. You don't need everything in the world to be ordered, right? So we already showed that transactions can achieve massive throughput and like very low latency without needing any order. And then if you think about auctions, essentially the order within the bid set does not matter, but the auction itself outputs an order, right? Because once you have an auction, you can order the bids, but the bid set, the ordering within the bid set is completely order independent. So when you do an auction on pod, the output is an ordering, right? But then you can also think of like social feed, right? If you think of like Lens or Farcaster, if these are like, again, the ordering doesn't matter, right? As long as the eventual consistency holds. And as long as my local feed is correct, I should be able to merge it with your local feed and show you a feed of things that happen. Similarly, data availability protocols, like, it doesn't matter if the data was posted now or then, as long as it's available and verifiable. So that's some of the ideas. I think games, again, the ordering doesn't matter. Think about Minecraft, like I'm mining some block here, you're mining some block there. Doesn't matter as long as, unless we mine at the same place. So
Deep, how did that all land for you?
Yeah, I understood the answer. I think the main thing was that what you said about ordering, that it doesn't matter anyway, that yeah, so I understand. It's just I think I need to update my knowledge of how these consensus systems work. In my what I understood, how the double spend problem is solved is that all transactions are run, and naturally they're run in the order, and that's how everyone arrives at the same state.
I think in this, what I have also taken away from looking at pod interest, you can say, is like there is still some synchronization that happens. It just is not required at that kind of like at the pipe level, which shows you have this much larger pipe, but then down the road, while immediately you don't have ordered transactions, at some point you do. And there are ways.
you don't order them ever. You don't order them ever. You can synchronize if you want to, but you would have to pay for the cost. You have to pay the cost of synchronization. So if your application needs synchronization for some reason, you could. It's not that eventually it will be synchronized.
That would be an application specific choice if required for that application.
Yes, exactly.
Thank you. Thank you for helping with that as well.
So I guess maybe one follow-up over there that I'm still trying to understand is that we may want to union the set and it should be sensible then. And we may want to synchronize based on an application specific use case. I think these things mean the same thing.
No, so
okay.
you have eventual consistency in the state, but that doesn't mean that you have an agreement. So agreement is a stronger property, which says that everybody at some point of time outputs the same result, right?
Yeah.
When we do like kind of a union, both of us agree on something, but the world might have already moved ahead, right?
Right.
You can go and you can pause the world and do a union of everybody, and then everybody agrees with that. Doesn't happen, right? That is synchronization. You have to say, everybody just stop, and then let's just merge our databases. And that is why it's expensive. That's what consensus does, is like the world stops, everybody shares their thing, does the union, and then you proceed.
Right. I see. So when the synchronization happens, there shouldn't be any conflicts, like,
And
It's
that is
like,
already guaranteed. So the pod guarantees that whenever you kind of merge states, it will never have conflicts. Like I cannot have two transactions. You cannot have a transaction. I cannot have a transaction that conflict each other because of what I earlier showed with the quorum argument that no two double spend transaction can get confirmed.
right. It's like Git work trees. If you merge them, there
Yeah.
shouldn't be any conflicts.
Yeah. Exactly.
I'm mindful of time, Shresth. I think we only booked 45 with you. I think this has been fantastic. Can you tell us what people should do if they want to learn more and how to engage? Maybe any parting words of thoughts for like people who are early stage in projects trying to get them off the ground.
Yeah, definitely. You can read more about Pod on pod.network. We have a lot of docs, a lot of stuff. We have a live DevNet. You can start building stuff. Happy, our team is happy to help in whatever way, shape, or form. Even if you're building some cool application not on Pod, feel free to reach out. I'm happy to help. But there is a lot of resources, and we have a live testnet, DevNet, and that you can play with, and would love to get people building fun stuff, cool stuff that requires all the performance that we've got. And we have a lot of cool ideas that people can start building on. We're planning to release something very soon on a very fast exchange on top of order book. It's not mentioned yet, and kind of dropping some alpha. And this is like going to be an order book based on auctions on Pod. And yeah, I'm happy to give like early access and stuff like that.
Cool. Thanks so much. Good luck in Argentina. I hope it's a lot of fun. It's always good to have you back. Thanks for coming for Fireside.
Yeah, thanks a lot for organizing this. I mean, it has been a butterfly effect since I joined Kernel. And yeah, I hope everybody gets to meet great people and come back 5 years down the line to tell their stories.
Yeah. Thanks so much. Yeah, I want to double tap for everyone. I think Shresth is right in the middle of the most important research that's happening effectively all throughout crypto, um, both on Pod specifically and in the way that he's basically been learning in public with a lot of the best in our industry. And I think watching how he's been able to move through those circles and the things that he's learned over the years has been an inspiration to us. And so Kernel is definitely better because you're here. And yeah, may it continue. Excited for the next 5 years.
Thank you.
Take care.
Bye-bye.
Bye-bye. If anyone else from Kernel wants to stick around, we can kind of debrief as we do. I know that this in practice was a very specific example of a principled game, but I wanted for it to showcase, like, first of all, like what's kind of going on at the base consensus layer of Ethereum. I think it was kind of like explored by way of how you could improve it. There are obviously trade-offs that Pod is making, and it's in general hard to get a new network off the ground. But I think that his intuitions are based off of this hope to scale principled game and based on just genuine learning that I think is nice to have heard. So if there are any reflections on Shresth's point or any other broader reflections on principled games, I would gladly hear them now from the crew.
How is Kernel a game?
It's funny. One of the things that this module has is, again, this little Easter egg on uncensored learning. And if we're trying to encourage a game, I think that that's one example. I think that when you're leveling up in a game, kind of feels like you're cultivating new skills that then open up the world to you in a new way. And if something is happening in kernel, we hope it's that you feel like you're leveling up in some way, shape, or form, and that the environment is encouraging that of you. There's a bit more that could be said, and there is a whole module that I know, Charles, you'll at least remember, if not, I've seen recently, but there's this whole module on games that Paul Gotti helped to create. And one of them is on a book that we really liked called Finite and Infinite Games. And I think that this uncensored learning one is very much in the infinite category.
Thanks for the riff. Yeah.
Thank you. Thank you. Thank you. Cool. Okay. Well,
You know,
we're
I
in.
I
Go
I
ahead.
just tag on really quickly, just because it's a thing I love to share, which is relating to pedagogy, which is peer-to-peer learning. It's a kind of pattern language, open source handbook, pedagogy.org, shout out. But it turns out that the patterns are basically the same, overlapping peer learning and peer making, peer production. So I just wanted to kind of speak that along with what you just shared. Yeah.
Yeah.
So
How would you
uncensored making
describe?
as well, and co-making, in community and so on. Yeah.
Yeah. How would you describe the difference between peer learning and peer making?
I wouldn't necessarily. I mean, and I mean, I think the point I'm making is that the line is fuzzy or not really there, actually. And I haven't gone back to that text in a while, pedagogy. I was involved some years back, but they're doing some great things still, by the way, like now with language models and so on. But taking these pedagogy principles, which a lot of the pedagogy, the learning or education dimensions tend to dominate or overshadow the production part from in their world. It's more in the ed space, let's say. But yeah, it's something I'd like to spread and not forget. Yeah.
It's amazing. Just shared it in the chat if anyone else is interested. Thank you, Charles.
And they have, just to say, a Google Groups, it's a listserv, but it's all open. I mean, I think you can view it, but you can join it to engage. And some of the things like around their advances on writing papers, also around this bringing pedagogy and AI together. That's a lot of where they're at now. Yeah.
Very cool. Very cool. Howard Rheingold and team, its team. That's great.
Yeah,
Anyone?
Rheingold coined the term, but then the cohort, his students basically took it. Yeah.
Cool. Cool. Any other thoughts or reflections? Also welcome any thoughts on like your work and things that you're looking for as we get closer to the end of the block. We'll be getting closer to showcase, aiming for about 3 weeks from now, 2.5. So getting towards the end of KB11. Excited to jam with anyone here if you'd like to share your work, whether now or later. I sense maybe later will be better, but happy to chat if anyone has anything else on the topics of the day. Cool.
No, it was just, yeah, it was a great session, just hearing Shresth, and I look forward to kind of tuning into that. A lot packed in there.
Yeah. Thanks. Thank you, Charles. Thanks, Deep and Verber, for your contributions. leave with a little quote from the module. When you learn something, you should be able to teach it to people. You should put the same effort into teaching as into learning. And if you want to teach, you should be humble enough to learn something, then you can teach. You try to teach just because you know something, you cannot teach anything. When you're ready to be taught by someone, then, if necessary, you can teach people in the true sense of the word. But to learn is to teach, and to teach is to learn. Hope everyone has a good day. Take care. Please reach out anytime. Talk soon.
Thank you, everyone. Bye bye.
Thanks again.
Bye.